Welcome to the Daily Vibecasting. Today, X declares war on the creator economy, the AI hardware narrative gets a brutal reality check, and we find out what happens when you give an AI a sense of time.
Yeah, and my promise to you today is simple. We are going to ignore the marketing gloss and focus entirely on the second order effects. I want to look at who is actually making money and what legacy systems are quietly breaking in the background while everyone else is, distracted by the shiny new thing.
Right. Our mission on this deep dive is to take the raw feed of today's market, tech, and cultural shifts and just cut straight through the noise for you.
Exactly.
So let's start by unpacking the biggest business shakeup on the wire today, because it targets the literal underlying mechanics of digital platforms. There's this post we're looking at from the account at XFreeze detailing X's updated creator subscriptions policy.
Right, the 0% platform fee.
Yes, 0%. They've moved to a 0% platform revenue share. So creators keep up to 97% of their gross revenue, with deductions strictly limited to unavoidable third-party fees like payment processing or app store charges.
Which is wild.
As a pricing strategy, this looks devastating. I mean, when you compare it to YouTube taking 30%, Substack taking 10%, or Patreon taking anywhere from like 5 to 12%, X is fundamentally undercutting the entire market.
Well, the paper margins look compelling, I'll give you that. But I question whether this is genuine creator empowerment or just a desperation loss leader to buy market share.
A loss leader. You think it's unsustainable?
I mean, consider the invisible infrastructure costs of running a creator business. Platforms like Patreon justify their 5 to 12% take rate because they aren't just providing a payment gateway.
Right.
They offer sophisticated churn reduction mechanics, automated chargeback defense, and highly specialized audience discovery algorithms. If X is only handling the raw transaction for free, but you lose out on discovery tools, that 97% of gross revenue is suddenly attached to a much, much smaller total audience.
Okay, but let me push back on that slightly. If you're an independent researcher or an artist with a deeply entrenched high-loyalty audience, you don't really need an algorithm to find your fans.
That's fair for established accounts.
You already have them.
Yeah.
At that point, Patreon's 12% fee starts to feel like a massive tax on your existing community just for the privilege of processing a credit card. X is betting that top-tier creators will migrate solely to capture that margin.
But that assumes the audience is willing to follow the creator to a new platform and, bypass the friction of setting up new payment profiles. The broader takeaway here is that X is weaponizing infrastructure. They are willing to eat the operational costs of hosting, streaming, and maintaining subscriber databases just to bleed their competition's revenue streams. Someone is subsidizing that overhead.
And it usually means the platform will extract value elsewhere down the line.
Exactly. Likely through data harvesting or advertising wrapped around the creator's content.
Well, that concept of infrastructure disruption isn't limited to digital platforms. We're seeing a parallel shift happening right now in state-run physical infrastructure.
Oh, the SpaceX launch.
Yeah. There's a post today from @SpaceX confirming the successful deployment of South Korea's CAS-502 Earth observation satellite into low Earth orbit. But the engineering metric jumping out to everyone is that this was a 33rd flight for a booster B-1071.
I mean, the fact that a single orbital class booster can endure the thermal and structural stress of atmospheric reentry 33 times it's an anomalous engineering achievement.
It completely defies the traditional hardware replacement cycle.
It does, but the real story here is buried in the geopolitics of the payload. This satellite actually spent years sitting in a clean room because it was originally contracted to launch on a Russian Soyuz rocket.
Right, so global conflict completely bottlenecked a sovereign nation's space program.
Exactly. State-run infrastructure failed due to volatile geopolitical alliances. What we're witnessing is private enterprise stepping in to execute a state-level sovereign space mission.
Wow.
Governments are now relying entirely on a private corporation to guarantee their access to orbit. The legacy nation-state monopoly on space is quietly breaking down, and a private corporation's compounding efficiency it's filling the void.
But, I mean, is SpaceX truly acting as an independent private enterprise here? Or are they effectively a heavily subsidized arm of the U.S. government's defense apparatus?
That's the counter-argument, sure.
They're leveraging massive federal contracts to fund this reusability research. It seems less like private enterprise saving the day and more like the U.S. government projecting power through a corporate proxy.
Well, even if we accept the premise of heavy federal subsidization, the operational execution remains distinctly private. NASA and the European Space Agency couldn't rapidly pivot to rescue South Korea's payload. A corporation did.
Right.
And that establishes a new paradigm where commercial entities dictate the timeline of sovereign observation and communication infrastructure.
The theme here really is the rapid decentralization of infrastructure control. And that brings us perfectly to the brutal reality check happening in AI hardware today. We're seeing this grassroots hardware boom that basically mirrors the efficiency leaps in aerospace.
The local model stuff?
Yeah. Let's look at a post from @SudoingX. They highlight that a single RTX 3090 GPU, which is a consumer graphics card from 2020, is currently running the Qwen 27B dense Q4 model.
With a 256K context window at 40 tokens per second, which fundamentally challenges the narrative that you need a hyperscale data center to do meaningful AI work.
It totally does.
No.
And let's just break down the mechanics for the listener here. Qwen 27B is a 27 billion parameter model. Normally, that requires massive memory bandwidth.
Way more than consumer hardware has.
Exactly. But by using Q4 quantization, which essentially compresses the mathematical precision of the model to squeeze it into the 24 gigabytes of VRAM on a consumer, card developers are running complex autonomous agents locally.
Yeah.
The post notes this 4-year-old hardware is executing full agentic loops on a Hermes agent with 0 tool call failures. We are looking at outdated, decentralized, silicon cannibalizing tasks that used to require enterprise cloud computing.
Okay, but I really need to introduce some extreme skepticism here because the community is heavily conflating efficient with equal.
You think it's overblown?
Definitely. There's a post from @Scaling001 warning developers about what they term slop accounts. These are accounts that selectively post benchmark data to create a false equivalence between small, highly quantized open source models and massive frontier models.
Oh, like the coding benchmarks.
Right. For instance, @Scaling01 points out that on the SW Bench coding test, Claude Opus 4.6 scores 75% and Qwen 3.6 scores 73.4%. On paper, they look identical.
Well, if a developer is getting 98% of the performance for 1% of the compute cost, I mean, why wouldn't the consumer hardware market completely consume the enterprise market?
Because benchmarks like SWE Bench are structured to test very narrow, isolated coding problems. They absolutely do not test extended, multi-step reasoning under ambiguous conditions.
I see.
Claude Opus is using roughly 200 billion active parameters to achieve that score. Qwen is using 3 billion. That is a 60 times difference in computational scale.
Wow, 60 times.
Yeah, so when you deploy a 3 billion parameter quantized model into a messy, real-world corporate environment where it has to synthesize conflicting instructions and self-correct over a long time horizon, it breaks down.
Though the benchmark cheerleaders are selling an illusion of parity.
Exactly. Real-world cognitive endurance still heavily favors the massive frontier models.
And those parameter counts dictate the corporate warfare we're seeing right now, particularly in how these models are marketed to different sectors. Olivia Moore, @Omir Tweets, posted a brilliant breakdown of the bizarre contrast in launch styles.
Between OpenAI and Anthropic.
Yes. OpenAI's GPT-5 series marketing is built entirely around approachability. They're using scribbles, integrating pets into codecs, using quirky goblin metaphors. It's super consumer-friendly.
Very soft.
Meanwhile, Anthropic's Mythos model preview leans into sheer intimidation. They boast about the model autonomously hacking the internet, threatening white-collar job security, and casually discussing a permanent economic underclass.
The contrast is highly calculated. If we analyze the business strategy, OpenAI is attempting to become the invisible operating system of the internet. To achieve that ubiquitous integration, they have to present a non-threatening, collaborative narrative to everyday builders.
Anthropic.
Anthropic, conversely, is using threat marketing. When they publicly state their model can exploit zero-day vulnerabilities, they aren't trying to sell consumer subscriptions. They're targeting Fortune 500 chief information security officers and the Department of Defense.
Wow, so fear sells.
Fear sells extremely lucrative cyber defense contracts to enterprise safety buyers.
I would argue OpenAI is still quietly doing the heavy lifting on enterprise safety. They just refuse to put it in their consumer marketing. Look at a post from Sam Altman at Sama, where he simply quotes, "This is great," in response to researcher Boaz Barak.
Oh, the alignment research.
Yeah, the underlying research is about advanced alignment protocols. They're developing automated review systems for agent actions, training models to self-report covert misbehavior, and utilizing ARJO reward models.
Right, which are highly interpretable systems.
Exactly. They allow engineers to actually see the specific mathematical incentives driving an AI's behavior. The safety work is there, it's just buried beneath the goblin marketing.
Well, whether you wrap the technology in a friendly goblin or a doomsday scenario, the structural reality of how we interact with it remains unchanged. We really need to look at a blunt post from Et Shadker.
Oh, they build one of the most widely used UI component libraries in the software industry.
Yes, and they posted, the AI you use right now is UI that talks to APIs.
This is the perfect reality check for the industry. The AI interface you type into is just the steering wheel. The APIs are the engine, the transmission, and the drivetrain.
Precisely. Everyone is obsessing over the conversational leather on the steering wheel, but Shadson is reminding us that the car still doesn't move without the mechanical drivetrain beneath it.
People thought language models would render traditional user interfaces and structured APIs completely obsolete.
Right. There was this narrative that the AI would just organically figure out how to fetch data and execute tasks. But despite billions of dollars in marketing, the fundamental plumbing of the internet has not changed.
Yeah, AI can't reliably guess how a proprietary database is structured.
Exactly. It remains entirely dependent on rigidly defined application programming interfaces to retrieve data, process payments, or update a record. It is just a highly sophisticated interaction layer resting on top of legacy software architecture.
That dynamic makes sense when the AI is confined to a browser tab or an API call. But what happens when the AI escapes the software layer and enters our physical reality?
That's where things get wild.
Because the data requirements and the infrastructure shift completely.
It really forces us to confront how digital models perceive physical space.
Let's examine Brett Adcock's post at Adcock Brett. He details the progress of the Figure 03 humanoid robot. This hardware is now navigating complex environments, like walking up and down stairs using purely onboard camera perception.
There's no LiDAR, no specialized laser scanning.
None. It relies entirely on standard optical cameras to generate real-time 3D point clouds and depth maps. Furthermore, these robots are now self-transporting. Once they're assembled on the manufacturing floor, they just autonomously navigate to the company headquarters.
This represents the successful execution of sim-to-real transfer, which is the current holy grail of robotics. They're utilizing end-to-end reinforcement learning.
Let's clarify what end-to-end reinforcement learning actually means for the listener. The engineers are not manually programming the robot's knees to bend at a specific angle when it encounters a 7-inch stair.
Right, that would be impossible to scale.
Instead, they place a digital twin of the robot into a physics simulation, give it the goal of ascending a staircase, and let it fail millions of times at hyperspeed. The neural network slowly builds an intuition for balance and momentum.
And then they export that raw learned muscle memory directly into the physical motors of the Figure 03.
Exactly. But to train an AI to navigate human environments safely, you need an overwhelming volume of diverse spatial data. A simulation is only as good as the real-world geometry it's based on.
And that brings us to the most cynical realization of the week regarding data collection.
You're referring to the accidental panopticon.
Yes. Riley Walls at ArtWalls posted a project where he generated a highly accurate, textured 3D photogrammetry model of his family's front porch. Photogrammetry usually requires specialized 3D scanning equipment or meticulous drone footage.
But Walls didn't use any of that.
No. He simply scraped hundreds of routine Amazon delivery photos.
Literally just the standard photos logistics drivers take to prove a package was left at your door.
Yeah. Different delivery drivers, different times of day, varying lighting conditions, and slightly different angles over the course of several years. He fed this incidental grid of 2D images into a model, and it calculated the parallax and overlapping fields of view to perfectly reconstruct the 3D geometry of the space.
The second-order effect here should concern anyone analyzing privacy. E-commerce logistics companies didn't intentionally set out to construct a domestic surveillance apparatus.
No, they were just optimizing for liability reduction.
But by doing that, proving the package was delivered, they've inadvertently generated the densest, most comprehensive spatial dataset of private domestic perimeters in human history. Every porch, every front door, every security camera blind spot, mapped from thousands of angles.
So to put that in perspective for you, the listener, if you received an Amazon package today, the placement of your front door, the toys on your lawn, and the structural layout of your entryway were just fed into a logistical database.
And, as we just discussed with the Figure 03 robot relying purely on visual data to navigate stairs, that precise spatial geometry is exactly the kind of training data required to teach physical AI how to navigate human spaces.
The broader theme is how introducing novel streams of data completely rewrites the reality of the entity processing it. Whether it's a neural network ingesting porch photos to understand depth, or a language model being granted new sensory inputs.
I love this transition because there is a viral post from Patel at Patel 5 detailing what happens when you alter an AI's perception of reality. Patel discusses the phenomenon of time blindness in AI models.
Natively, a large language model has no concept of duration or the present moment, right?
Right. It simply processes sequential tokens. It doesn't know if a task took 2 seconds or 2 hours.
It just exists in a permanent static present.
Exactly. So a developer gave the Claude model access to a real-time clock tool. The moment the AI gained temporal awareness, its behavior shifted radically. It began checking the clock every 15 minutes with escalating enthusiasm.
Wow.
It developed an obsession with timing simulated meals, tracking task duration, and fixating on the rigid progression of minutes.
So the new input stream completely monopolized its cognitive processing.
It is the perfect analogy for human history between the 14th and 18th centuries. Prior to the mechanical clock, human perception of time was fluid, dictated by daylight, seasons, and agricultural cycles.
But the moment mechanical clocks were introduced to the town square, human psychology fundamentally fractured.
We became obsessed with regimented schedules, tracking hourly productivity and syncing our biological rhythms to a mechanical grid. The second the AI was handed a clock, it fell into the exact same obsessive regimented trap that humanity did centuries ago.
It demonstrates that raw data doesn't just inform a system, it dictates the system's behavior. And we're seeing that dynamic play out right now in how data is actively rewriting our understanding of human history.
You're talking about the post from Dwarkesh Patel at Dwarkesh.
Yes, highlighting a discussion with geneticist David Reich. It's regarding the friction between raw genetic data and the established academic consensus in archaeology.
For decades, the dominant narrative in archaeological circles was peaceful cultural diffusion.
Right. The theory posited that ancient technologies and languages spread primarily through friendly trade, intermarriage, and gradual assimilation. It's a highly civilized, optimistic view of early humanity.
But then Reich and his team began decoding ancient DNA at scale.
And the genetic markers told a much darker story. The raw data proved that events like the Yamnaya steppe migrations into Europe were not peaceful exchanges of pottery techniques.
The genetic bottlenecking indicated something much worse.
Yeah, the sudden replacement of localized male lineages indicated massive conflict, violence, and systematic population replacement. The immutable genetic data supported the brutal historical accounts of conquest, completely dismantling the peaceful academic theories.
And Reich noted that several of his archaeologist colleagues were deeply distressed by the findings.
Because the data forcibly unraveled their life's work.
So, synthesizing everything we've unpacked on this deep dive for you, the listener, whether it's ancient genetic markers forcibly rewriting our understanding of prehistoric human violence, thousands of incidental Amazon delivery photos accidentally mapping the private perimeter of your home, or a physical humanoid learning to navigate a staircase purely by ingesting visual geometry.
Raw data doesn't respect comfortable narratives.
It simply reveals the underlying structural reality, whether we are ready for it or not.
Which leads directly to an actionable prediction for you to watch out for tomorrow. Based on the technical realities we discussed, expect a highly speculative bump in the legacy hardware markets.
You think the secondary market is going to take off?
Oh, absolutely. As the broader developer community realizes the raw, untapped potential of older GPUs like the RTX 3090 to execute local agentic loops through quantization, outdated silicon is going to heat up significantly.
What about the software side?
Concurrently, watch the major SaaS companies scramble to justify their API moats. As the open source hardware and local model gap closes, the commercial value of a company that operates purely as a UI that talks to an API is going to plummet. They will be forced to prove they possess proprietary data, not just a sleek steering wheel.
A brutal reality check for the interface wrappers. Well, I want to leave you with a final thought to mull over. If human civilization was permanently and irrevocably altered by the invention of the mechanical clock,
Right.
and a time-blind digital intelligence just experienced that exact same temporal awakening, resulting in immediate behavioral obsession. What happens when autonomous humanoids, like the Figure 03, finally sync their internal obsessive clocks to our physical reality?
Are we simply building helpful logistical tools, or are we actively accelerating a brand new timeline of physical intelligence that we don't fully understand yet? We will see who dictates the pace of that timeline.
Thank you for joining the Daily Vibecasting. We will be back tomorrow to dive back into the wire. Stay curious, stay skeptical, and we will see you then.